Hello students, today we will study the examples, some of the examples. These are the examples of standard 10 chapter number 6 triangles. Let us study the example number 2. What is the question? The question is ABCD is a trapezium with AB parallel to DC. E and F are the points on non-parallel sides AD and BC respectively, such that EF is parallel to AB. We have given here one of the diagram. So we have to show that AE upon ED is equals to BF upon FC. So this is what we have to show, that AE upon ED is equals to BF upon FC. So this is a trapezium ABCD, and this is BF is the line which intersects AD in a point E and BC at a point F, right? So here this trapezium is such that this line, the side AB is parallel to side DC. Okay, so let us start. Here we have given that AB is parallel to DC, right? This is the according to the property of the trapezium. These sides are parallel. Okay. One more thing we have given that EF is parallel to AB. So here this EF is parallel to AB. EF is parallel to AB. Now see, AB is parallel to both the sides. AB is parallel to DC and AB is also parallel to EF. So the theorem that we have studied in standard 9, that the lines which are parallel to the same line are parallel to each other. That means if AB is parallel to DC and AB is also parallel to EF, that means EF and DC are also parallel. So in short, AB, EF and DC all are parallel to each other. So here we can write down one of the statement that AB is parallel to EF is parallel to DC. All the three sides on the three lines are parallel to each other. Okay. Now, whatever we have to prove is AE upon ED is equals to BF upon FC. So let us first of all think that whatever we have studied till now, that is theorem 6.1 and 6.2, basic proportionality theorem and the converse of that theorem. So that theorem is only for the triangles. It is not for the trapezium or any kind of quadrilateral. So whatever we have to do, first of all, we have to draw a diagonal AC so that this trapezium is divided into the two triangles. One is triangle ADC and one of the triangle is CAB. Because whenever we have the triangle, then only we can apply the theorem 6.1. Otherwise, we cannot apply the theorem 6.1. So let us draw AC. Now draw AC and it intersect EF at point G. Whatever we have drawn the diagonal AC is intersect this EF at a point G. So now you can see that there is a triangle ADC. So let us first of all, whatever we can find out from this triangle ADC, let us find out. So in triangle ADC, what is in the triangle ADC? We can say that EG is parallel to DC. EG is parallel to DC. Why? Why EG is parallel to DC? Because EF is parallel to DC. That we have already here proved. Right? So if EF is parallel to DC, then EG is what? One of the portion which is on the EF. So this portion is also parallel to DC, right? Okay. Now, as this EG is parallel to DC, then we can write down that AE upon ED is equals to AG upon GC. AG upon GC. Why? According to the theorem 6.1 or according to the theorem basic proportionality theorem. So this is the first result that we have to use to prove this, right? Here you can see that AE upon ED is now we have. Now we have to find out BF upon FC. So now you know that as we have applied this theorem to the triangle ADC, in the same way we now have to apply this theorem to this triangle CAB, right? Okay, so now let us write down that in triangle CAB, GF is parallel to EB. GF is parallel to AB. Why? Because GF is on EF and EF is already parallel to AB. That we have already proved here. Right? So again, according to this theorem 6.1, we can write down that GC or we can write down that GC or CD. GC upon AG is equals to CF upon FB. CF upon FB. This is also we can write down that according to the theorem 6.1. Now see, this result, here we want BF upon FC and here we have BF upon FC. Okay, here also we can write down it as a BF upon FC or FC upon, here we have write down that GC upon AG, then here we have to write down FC upon BF. BF or FB, that doesn't matter. But as here we have write down it as a BF upon FC, so that is why we are taking as a BF and FC. But if we write down CF and FB, doesn't matter, right? Both thus are equal. So give it equation number 2. See, now we can compare this AE upon ED and AG upon GC with this thing. But here the numerator is in the denominator and whatever the denominator here is the numerator. So now we can interchange this ratio, right? We know that we can write down it as a AG upon GC is equals to BF upon FC. BF upon FC. Give it equation number 3. Now we can compare this equation number 1 and equation number 3 because here AG upon GC is in both the equations. So when we compare equation number 2, equation number 1 and 3, then by comparing this we can write down that AE upon ED is equals to BF upon FC. So see, whatever the result we want, we get here is AE upon ED is equals to BF upon FC. So this is the result we want. One thing you have to consider, that is we can apply this theorem 6.1 into the triangles only. We cannot directly apply this to the any quadrilateral. That is why we draw one of the diagonal AC. Here you can also draw this diagonal BD. By drawing the diagonal BD, we can also prove the same result. Okay, so this is you can do as your exercise. Okay, now let us study the example number 3. So what is the question? Question here is, in the given figure, PS upon SQ is equals to PT upon TR. right? And angle PST is equals to angle PRQ. That is already whatever we have given in the question. Prove that PQR is an isosceles triangle. So what we have to prove? We have to prove that triangle PQR is an isosceles triangle. An isosceles triangle. That we have to prove here, right? Okay, so we have given the two things. Let us first of all understand this diagram and what is we have given. Here we have given one of the triangle PQR. One is the line ST, but see, we do not have given that ST is parallel to QR. That we do not have given. Instead of that, we have given one thing is that PS upon SQ is equals to PT upon TR. And second thing is angle PST. This angle PST is equals to the angle PRQ. That we have given here. Okay. So what we have to prove here is we have to prove that triangle PQR is an isosceles triangle. Now let us first of all think how we can prove this. Isosceles triangle means if the two sides of a triangle are equal, then we can say that the triangle is an isosceles triangle. But here we do not have given such kind of things, but we have given one of the angle, that is PRQ, right? We have given that angle PRQ is equal to this angle PST. So anyhow, if we can prove that this angle and these angles are equal, then the opposite sides will be equal. That we have studied in standard 9. But how we can prove these angles and these angles are equal? See, here we have given these two angles are equal. So anyhow, we can prove that these two angles are equal. Then it will be possible to make this both the angles equal. So now how we can prove these two angles are equal? If these two lines will be parallel, then this PQ we can consider as a transversal, and those two angles are making a pair of corresponding angles. And in this way, we can prove that both these angles are equal. So now we have created one of the path in our mind. What we have to do? We have to prove that ST is parallel to QR. And to prove that, see, whatever we have given is PS upon SQ is equals to PT upon TR. Now, according to the theorem 6.2, if a line divides the triangle, two sides of a triangle, into the same ratio, then that line is parallel to the third line of the triangle. So here we can say that ST is parallel to QR according to the theorem 6.2 that we have already studied, right? So now what we required is here ST is parallel to QR, and now therefore we can write down angle PST is equals to angle PQR. And why we can write down is that according to the corresponding angle, right? According to the corresponding angle, both these angles are now equal. So see, this angle PST and PQR are now equal. And whatever we have given here is angle PST is also equal to angle PRQ that we have given. So when we compare both these equations, we can write down here is that, therefore we can write down angle PQR is equals to angle PRQ, right? And therefore we can write down that opposite side of this PQR is PR, the side is PR, and opposite side of PRQ is PQ. And therefore we can write down that if the two sides of a triangle are equal, we can say that triangle PQR is an isosceles triangle. Right? This is the result. And how we can write down this result is that sides opposite to equal angles are equal. That result we have already studied in standard 9. So this is how we can prove whatever we have to prove in any questions. But first of all, you have to clear the path. You have to clear your way how you are going to prove any problems. Okay. So when you can do these things, you can easily solve this type of questions. Okay. So this is all about this lecture. Thank you.